Hello everyone, this is R. Suresh Kumar, working as Assistant Professor, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we will discuss an important topic regarding the irrigation efficiency. In the previous lectures, we discussed about what is meant by irrigation, types of the irrigation, how different type of the crop irrigation can be duty, delta, like I discussed in the previous lectures. Now we have to discuss about the irrigation efficiency. So irrigation efficiency is first, before going to entering the topic, I have to some discuss about the water losses in the canals. There are going to be used different type of the canals can be out. So the first one is evaporation from the waste from the water surface. Next, deep percolation to soil layers and underneath of the canals, and seepage through the bunds of the canals, and overtopping bunds and bund breaks. So runoff in the drainages and rat holes in the canals. So like that, these are some of the can be water lossing without any hour. So they can be rectified. The first, what we discussed about the losses, different type, and can be rectified. Then you can be save the water. So next, water losses, there are the surface run. Another is the surface runoff at the water and in the drainage, and another one is deep percolation of the soil layers, which also the root zone. These are all some of the depends upon the criteria of the water losses. Next, you have to go the irrigation efficiency. So what is define the irrigation efficiency? What is meant by irrigation efficiency? Irrigation efficiency is the percentage the part of the water is pumped of the delivered through the scheme, inlet and used efficiency by the plants. The irrigation efficiency is a critical measure of irrigation and perform the terms of the water required to be irrigate as a field, a farm and entire watershed. Next, the objectives of the irrigation efficiency is that the concept of the determine. So whether the improvement can be made through the irrigation system and the management operation of the program, and will lead to efficient of the irrigation of the water efficiency. So irrigation efficiencies are highly depends upon, first of all, system design, and second one of management, and third one is maintenance, and fourth one is weather, and fifth one is operating conditions. There is some other system design, how the irrigation canals, how the irrigation system can be types can be constructed, and how the different type of the soil depends, as we discussed in the previous slide, as the type of the soil and percolation and losses. These are also depend upon the system of the designing. Next one is management, how to manage the water of the water can be fully utilized. That is a very important. The utilization of the water, how we have to take the steps by the maintaining of the management of the water. Next, the maintenance, how the after the construction the water is flowing okay, but it can be maintained. How can you have to maintain throughout the supervision is very important for the maintenance. Next, the weather. So weather condition is very important. How the weather condition is important is the weather is not a hot area, as we know that the evaporation losses can be done in the especially in the summer area, as we know that very well. The water can be evaporated and the losses will be the more. Next, operating conditions. Which type of the operation conditions can be used for the efficiency, highly water efficiency or irrigation efficiencies? So different type of techniques can be used, operating and new techniques can be used for the maintenance and the operations of the conditions of the irrigation efficiency. Next one is several terms of the used to evaluate the irrigation performance. What are they? The first one is water conveyance efficiency, and water applied efficiency, and water storage efficiency, and water distribution efficiency are uniformly coefficient. Next one is conceptive use of the efficiency. So these are the efficiencies can be used for the evaluate the irrigation system, and it can be a guide to the how the irrigation system can be water can be utilized as the most without losses, how the water can be utilized. There are some of techniques can be used for this irrigation systems. The first one is water conveyance efficiency and water apply efficiency, water storage efficiency. So conveyance means how the water can be flow from the one place to another place, which of the conditions as we discussed in the previous, what are the conditions, what are techniques can be used, can be important. Next, application of the efficiency, how the techniques, the techniques can be known, but how the techniques can be applied, these are very important. Next, water storage efficiencies, how the storage efficiencies can be constructed. Next, distribution efficiency and the distribution of the water are uniformly coefficient. So later on we discuss each and everything, and conceptive use of the efficiency. These are the main of the efficiencies of the water usage of the system. Next one is irrigation efficiencies. As we irrigation efficiencies can be, let us see the discussion. The efficiencies is the ratio of the water output and water input, and is usually expressed in the percentage, and can therefore the efficiencies is the loss. Hence the efficiency is inversely proportional to the losses where the water irrigation is during the various process, and therefore the different kinds of the irrigation efficiencies can be given below. So what are they? Let us see the water conveyance efficiency. The first one, water conveyance efficiency, as we discussed in the previous one. Water, first one is water conveyance efficiency. What is meant by water conveyance efficiency? In the ratio, it is the ratio of the water can be delivered, how much water can be delivered to the fields, and the outlet of the point of the channel. As I told, one point, another point of the channel. The water is pumped into the channel at the starting point. It takes the conveyance or transit the losses into the account. So let us see water conveyance system can be expressed in the equation y is equal to water delivered to the farm by water delivered from the river or the reservoir. Water delivered from to the farm to water diverted from the river or the reservoir. So WF by WR. That is the water conveyance of the efficiency by water conveyance of the water. Next, water conveyance efficiency. Water conveyance efficiency. Next, we have to be. It is used to measure the efficiencies of the water conveyance system and associated with the canals as the field channels as well as the pipelines. So these are the conveying. Conveying nothing but to transport the water from one place to another place for the irrigation system. What we have to, which are the methods can be used for supplying of the water, whether the pipeline or canal, whatever it is, the medium, whatever it is, the water conveys to one place to another place for the utilization of the purpose without any losses. Next, the irrigation of the water can be delivered from the storage of the reservoir and transported to the field farm, the system of the canals or the pipelines. It can be pumped from the reservoir on the farm of transported through the system of the farm and the canals and the pipelines. Canals and the pipelines. These are the irrigation of the canals of the system. So canals, pipelines, as I told, the pipelines can be used from one place to other place. Those are delivering the water for the irrigation fields. The water availability is less. We can transport it from one place to another place toward the pipelines. It is the very important to the convey. Next, normally the irrigation of the carried out, the conditions conveying the efficiency nearby 100% have been considered. It means the water which is delivered from one place to another, you have to think that it can be utilized, the 100% of the water can be utilized, can be very important. Next, conveyance of the losses of the include any of the canals, spills or operating of the canal system, the reservoir seepage and evaporation that might result from the management as well as the losses of the resulting from the conditions. the irrigation of the system. It is also include leakage from the pipes. So leakage of the pipes is also one of the losses of the water efficiencies. So the efficiency doesn't matter. You have to be how much water can be exactly utilized. So it losses can be more. What happens? The percentage of the utilization will be there. Automatically it can be reduces. So that is the next. Typically the conveyance of the losses must be lower the closed conduits, and it can be compared to the unlined or lined canal due to reduced evaporation and seepage losses. Next, water application efficiency. Water application efficiency. Let us see water application efficiency. Let us see the second one. This is the second one, water application efficiency. Okay, so the second one we are going to be discussing. What is meant water application efficiency? The water application efficiency is the efficiency. It relates to the actual storage of the water in the root zone. So meet to the crop to the relation to the water applied to the fields. So it means that, so there, for suppose there is a crop and there the roots will be like that. The water which is absorbed here, water is flowing underground, which how much the water can be roots can be utilized and can be meet the crop in the water root zone, and crop of the needs relation to the water applied to the field. The application of the efficiency includes any losses from the from evaporation or seepage losses. Means evaporation losses can be due to the temperature, seepage losses due to the various conditions. It means that the soil conditions of the, as we discussed in the previous one. The seepage of the water which absorb the water can be seepage of the water. So the water of the canals, furrows, or leakages or sprinklings and the drip pipelines can be generally percolate beneath of the root zone. The evaporation droplets of the air are runoff of the field. This is the generally used for the water application. Application means which the type of the mode can be used for the efficiencies, water efficiency. Next one, water application is the effect of below 100% is due to the seepage losses and field distribution of the channel. The runoff can be percolation below the crop root zone. Water losses due to the ineffective application of the water field when varies can be 28 to 50% of the water losses. Generally have to be considered due to the inefficient of the applications. Inefficient of the application means what happens? So we have to cannot be control the losses from the whether it is surface or subsurface or the infiltration or percolation. So whatever it is, the losses we have to be controlled, not controlled. It can be affected the losses in the water due to it cannot be utilized. The wastewater can be easily through the grounds. Next, the water application efficiency can be expressed in the field. This is the water storage. It is the ratio of water storage in the root zone. In the root zone, how much water can be stored and during the irrigation time divided by water delivered in the farm. How much the water can be supplied and delivered, and which can be stored in the root zone. How much water can be stored in the root zone. Let us see that one. So it can be water can be stored in the root zone. How much water can be which is supplied in the top, whether it is rainwater, runoff, whatever it is, or may be supplied to the water to the pipeline. The mode of the supply is whatever it is, but it can be seen whatever the water can be utilized and storage of in the root zone. How much water can be delivered? How much water can be stored in the root zone? So this is the important factor which are going to be discussed. Next one is, so the proper irrigation system can be applied and also we can take the proper irrigation management can be result, and over irrigation may be result by leaching the chemicals below the crop growth zone and cause of yield of reduction and result in the wasting of the water resources and application of the efficiencies. Next one is over irrigation. Over irrigation may be result reaching the chemicals is below in the crop root zone, which is chemicals which is applied can be reduced the resulting the water zone, and it can be water resources wasting waste of the water resources. Application efficiency is equal to EA. Application of efficiency is equal to EA. EA means water in the root zone after the irrigation and total volume of the water can be applied. So EA is equal to total volume of the water applied minus volume of the tail water plus volume of the percolation. It can also mix, it can be bifurcated. The volume of the tail of the water how much plus volume of the percolation, which although water can be top and be flowing in the root zone can be detected from the total volume of the water is applied. So total water can be applied. So this is equal to, there is one formula for calculating. So application efficiency is equal to EA is equal to Vs by Vf into 100, where Vs is equal to volume of the irrigation water stored in the root zone. Vf is equal to volume of the irrigation water delivered into the field. Water can be delivered into the field. That is the one of the next. Water use efficiency. Crop water use efficiency is mostly used to describe the irrigation efficiencies as terms of the crop yield. It is defined as ratio of the mass of the crop yield per unit of the irrigation water and used for the evapotranspiration. High irrigation efficiencies can be offered. Next one. Lower the improvement of the production of the per unit of the water can be delivered to improve the environmental benefits as the and the management. Next, several adjustments can be done during the made of the volume of the delivered. The field of increased efficiency or uniformly may be spread over the water. Next, water use efficiency is equal to water use efficiency. It is the, so let us see that one before. Water storage efficiency. So let us see application of proper and water use efficiencies. Okay. Next, water use efficiency can be calculated. It is a ratio of the water when be beneficially used, including the leaching water to the quantity of the water can be delivered. So it can be water used consumptionally water delivered to the form W by W. By using this formula, you have to be find out the water use of the efficiencies. Next, water storage efficiency. So in the water usage efficiency, this is a water storage efficiency. The water storage efficiency is the ratio of the water can be stored in the root zone during the irrigation of to the water needed to the root zone prior to the irrigation. That is field capacity existing the moisture content. So that is equal to NS is equal to water stored in the root zone during the irrigation by water needed in the root zone prior of the irrigation. This is the, let us see one look for the water storage efficiency is equal to water stored in the root zone during the irrigation time. During the irrigation time means how much the water can be stored during the cultivation, how much the water can be during the irrigation time only. Next, divided by water needed root zone in the prior to how much the water can be needed for the irrigation purposes can be used. Next, uniformly coefficient of water distribution C is equal to, it is the effect of the irrigation may be measured can be water distribution efficiency which is below. ND is equal to 100 into 1 minus Y bar divided by T. So here what is meant by Y bar, what is meant by D? Let us see. I have to be discussed and D. So uniformly coefficient or water distribution efficiency, that is equal to D bar is equal to average depth of the store during the irrigation, and Y bar is equal to average numerical deviation of the depth of the water stored in the average depth of the storage during the water. So here D bar is equal to average depth of the water stored in the during the irrigation, average depth of the water during irrigation, and second one is average numerical deviation of the depth of the water can be stored in the average depth of the irrigation. Next one is irrigation efficiency, water distribution efficiency. That is equal. This is show how the uniformly water is applied over the uniformly applied to the entire the field. Entire the field have to be applied along the irrigation of the run. And the second point is nothing but if the sandy soil there is a general over irrigation upper reaches of the run, there were the clayey soils over the irrigation low reach of the run. What is the meaning of that one? Let us see that one. The sandy soils, what happened? The percolation capacity will be the more. So generally the irrigation, the upper reaches of the runoff will be there is a clayey soils, and therefore the irrigation of the lower value of the run is equal to 1 minus Y by D into 100, where ED is equal to water distribution efficiency. Second one is D is equal to average depth of the water in the penetration. Okay. Next Y is equal to average deviation from D, that is equal to by using this application you have to find water distribution efficiency. You have to find the water by applying this formula. We have to find the water distribution efficiencies. Next, irrigation efficiency. That is the one diagram is given the easily to understand the root zone of the underwatering has been here. Let us see that underwatering the root zones are given here, and cutting and scrolling of that one. Poor of the problem with the application of the ensure the plants can the adequate water with over water on the plants. That is the example of the good example of the water distribution uniformity. Distribution uniformity. We call DU nothing but distribution uniformity. The distribution of the here let us understand this one. This one is different. This one is different. The water with flowing will be the same level. It have to be scoring from the and on the area, the application of the depth. So it can be different of the depth from the problem with the depth, that is equal to T. Application of the depth of the water. So distribution uniformity or DU is equal to nothing but distribution uniformity measured how the uniformity of the weather can be applied, and DU is the measure of the irrigation of the system. It is the measure of the irrigation system. So that is the one of the system can be distribution of the irrigation when we applied as shown in the diagram. So irrigation efficiency, let us see that one application. It can be where the underwater DU, the example of the pool DU means here the, as I told, it can be changes the where the level will not be same. The root zones which is also inside can be different levels to not properly absorb the water. So based on this one you have to understand here how the efficiency, irrigation efficiency can be affected in that on particular of the zone. Application of the depth and underwatering. Next, the conceptive use of the efficiency. Conceptive use of the efficiency. Here the conceptive use of the efficiency is nothing but here the water distribution efficiency represents the extent uniformly depth and throughout the field. The water can be penetrated uniformly throughout the field, and also the delivered from the mean depth of the zero and also sorry, and also distribution of the efficiency is one. So let us see the discussion about the concept use of efficiency is equal to normal concept to use of the water It is the ratio of normal consumptive. Consumptive use of the efficiency is equal to, let us see, the normal consumptive use of the water divided by net amount of the water can be depleted from the root zone of the soil. By using the equation WCU by WD by water consumption by water distributed can be known by applying this formula. So overall efficiency, overall irrigation efficiency EO, overall efficiency is equal to the overall irrigation efficiency represents the efficiency of the physical system operating the decision and delivered the irrigation water supplied the source of the crop, and it can be calculated the multiplying the efficiencies of the water of the every conveyance of the application. EO is equal to, EO means something but efficiency of the overall efficiency of the water is equal to EC into EA into 100 percentage. So what is meant by EC and EA? EC is nothing but water conveyed efficiency. Water conveyed efficiency. And water conveyed efficiency, how much have we discussed about how much water conveyed one place other place by using the different type of the modes and apply whether pipeline or canal, whatever it is, without any losses, the losses of the water. And next EA is nothing but water application of the efficiency. How much water can be applied. So applied of how much supplied or applied of the water, how much quantity of the water can be applied. That is equal to EA in the EC. Therefore, overall efficiency is equal to EO is equal to efficiency of the conveying of the water is equal to overall irrigation efficiency is equal to EC into EA into 100 percentage. Next, the ways of the improving the efficiency. Already we discussed all the efficiencies which we in the previous slide, and now we have to be ways of the improving the efficiency. What are the ways to improve efficiencies? Water transport through the underground pipelines or any of the lining of the water resources, and also reduce the water and means then the topmost in the underground pipeline system it cannot be damaged due to any of the physical, whether it is physically or any other damages will be the less when compared to the topmost laying of the water. So not only that, it can be protected from the weather effects, whether it is temperature effect, whatever it is, it can also protected by laying the water pipeline in the underground. Next, reduce the water evaporation, seepage and leakages from the pipe. Very important. So what the conveying of the water irrigation efficiency have to be without any losses of the water is the very important from one point to another. So whatever the techniques you have to apply, don't bother about that. But it can be, water can be utilized maximum percentage of the losses can be reduced. Next, improve the equipment technologies and engineering. Latest advanced technologies can be have to be applied and without losing of the to avoid the losing and minimizing the losses of the water losses. Next, optimizing the total crop management. So total crop management is also using the techniques have to be to the one place optimization crop crop can be easily to convey the water be to the increase the crop, and it is also the earning of the crop percentage will be the more by using the some of the techniques of the efficiencies. Next, irrigation get a good design. So which one is good design? Good design means it when the new techniques can be applied for the how much the water can be without any losses can be applied. Next, maintain the irrigation system when properly have to be maintained. Some irrigation system is also, and replace the old nozzles and fix leaky pipelines and improve the management. Improve the management, next maintenance of the water pipeline or any of the water can be one place to another place. Next, irrigation schedule, how much the water can be scheduled. The operation are designed the pressure at the flow and irrigate on the calm cool of the days. Some of the irrigation efficiency point regarding the points. Next, the small definitions is there. Gross command area uncultivated area and cultivated area. So grass command area is the whole area which is included between whether it is imaginary, it is a boundary line which can be include the irrigation project of the supplying the water agricultural to the land network canals as known as grass command. It includes both cultivated and uncultivated areas, cultivated and uncultivated. So these are the mixture of the grass command area. Next, uncultivatable area. Uncultivated area is nothing but here the area where the agriculture cannot be done and crops can't be grown. So that's why these are the uncultivated area we call it as. Some of the marshy lands, bare lands, ponds, forests, villages, this we consider uncultivated. Uncultivated nothing but we cannot be intentionally not proper land, just like the crop. So it may be automatically it may comes. We are not cultivated. So that's such type of we called uncultivated of the system. Next, cultivated means the area which are agriculturally can be done satisfactorily. We intentionally we can do the irrigation. By using irrigation, the crop will be grown intentionally. Which crop have to be suitable for which type of the soil. So on some particular area and due to availability of the water. So such things we have to call it cultural command area. So cultural command area, total area within the irrigation project can be done. A crop within the be grown. The intensity of the irrigation. Intensity of the irrigation nothing but the ratio of the cultivated land for the particular crop and the total culturable command area. So that is equal to area intensity of the irrigation is equal to land of cultural area by cultural cultivated. Land of cultivated divided by cultural command area. So this is not intentionally intensity of the irrigation. We call it II. So land cultivated divided by CCA. CCA nothing but culturable command area. Next, crop season. Let us see some which is related to our topic. Crop season. From the agricultural point of view, the year delivered the two principal crop seasons. We know very well the Kharif season and the Rabi season. The Rabi season starts from the 1st of the October and ends with the 31st of the March. And the Kharif season will start 1st of the April and ends with the 30th September. Rabi crops are winter crops. So and example Kharif crops are wheat, barley, yam, linseed, mustard, potatoes, etc. Next, cash crops. Cash crops nothing but which is commercially have to be cultivated. So a cash crop nothing but defined which has to be encashed the market by using the growing of this growing of the such type of the cultivation. We consume directly to the cultivators. All non-food crops are thus included in the cash crops. Example, jute. This is the commercial crops. Here the commercially you have to use such type of the crops. Next, second one is the tea. Tea is also one of the commercial. Cotton is also commercial. Tobacco. These are the four which is not used, but it can be used commercially. Means the earning of this of the irrigation, earning of these crops will be the more commercial way you have to be used. That's why the earning of this one is amount will be also more. So such type of the called as the cash crops. Okay, thank you so much. We have to discuss different type of the now the irrigation efficiencies. Different type of the efficiencies has been discussed today. And thank you so much. Next we have to be meet as a very good topic. Until thank you.
Like, share and subscribe. Hit the bell icon for more updates.